relaxing.
Okay, so everyone, yeah, just a reminder, Monday is a holiday, so no class. Apparently it's Thanksgiving. So yeah, and I was gonna skip this class too as well, but I was like, we're already missing Monday, so let's do something today. And what else? And the second assignment is up. It's just posted early. And yeah, once we finish chapter 2, we'll figure out the due date for that. Someone said, Buddy the Bearded Dragon, what's your favorite color? I don't know. That's a tough one because he can't really talk, and I don't really know what colors he can see. He can see ultraviolet. So I'm just going to say, for the sake of coolness, that, okay, it's a quote. Okay. But just to answer the question regardless, they can see UV light. So I'm going to say that's his favorite color because that's badass that they can see UV light. Okay. So what else? I guess that's all for reminders. Okay, so let's start. And we're recording, good. So I couldn't remember what we did previously, so I briefly checked the YouTube videos. So it looks like we covered an introduction to ratios and proportions, and we learned how to solve basic proportions. It looks like that's what we did previously. So now we'll do a little bit of a recap on that, and then we'll go and do some word problems that use proportions to solve them. So let's see. So this is another lesson. It's just called Solving Proportions, More Examples. And it's exactly what it sounds like. It's just more examples of solving proportions. It's not super helpful because with solving proportions, there's only a limited number of problems that you can run into. There's really only 2 different iterations. There's one where the variable happens to be on top, and that's a little easier to solve. And then the variable happens to be on the bottom, and that's a little more difficult to solve. So we'll go through both of those cases just as a recap, and then we'll start on the word problems. And does anyone have any questions before we start? So everyone seems good. Buddy is nice and happy. Okay. So we established an important rule for solving proportions previously, and it was that you could take a number and move it from one side of the equation to the other, as long as you give it the opposite operation compared to what it had. So that means switching it from the bottom to the top or vice versa. And of course, the top is always associated with multiplication, and the bottom is always associated with division. So let's just do 2 examples. So here is the first one. So it says solve x over 5 equals 21 over 35. So I'm just going to write this right here. I just like to write the question regardless. Okay, let's see. So in this case, again, you can move something from one side to the other as long as you give it the opposite operation compared to what it had. And in this case, your goal is to solve for x. So whatever is near x or touching x, that is the number that you want to get rid of so that you can get x by itself. So for this one, you only just have to take the 5. And since it's division, because it's on the bottom, you change it to the top, put it on the other side, and change it to multiplication. So you get x is equal to 21 times 5 over 35, which is 21 times 5 is 105. 105 divided by 35 is something. I don't know what it is. Let's check. Where are my solutions? It is, oh, okay, it's just 3. That makes sense. So the answer in this case is 3. So for your therefore statement, you could just say, therefore, x is equal to 3. Or sometimes people just write out the whole proportion. So you could say 3 over 5 equals 21 over 35. And this one's pretty easy to confirm as being true because like you could just take the 21 over 35 and reduce it. And that would confirm that, yes, you would get 3 over 5 because you could divide this by, can you reduce this? Yeah, you could do this by 7 or divide by 7, and you would get 3 over 5. So that's kind of one way of double checking. But that's not always a reliable way. So we do have to use these formal rules of algebra. Okay, and now let's do one example where the variable happens to be on the bottom. So let's do this one. This one's kind of easy to guess, actually, because again, if you imagine taking a 5 out of the fraction on the right, you would get 12 over 11. So that kind of gives away the answer that x is going to be 11. But yeah, regardless, let's do this one. Okay, so 12 over x is equal to 60 over 55. This is the one where people have a lot of trouble with it because the variable's on the bottom, so they try to move a bunch of numbers around, but then the variable still just gets stuck on the bottom. So there was a trick that we went through with this one, and I think this is the best way to solve it, where you just reciprocate each side. You just invert it. So you just take this left side and flip the top and the bottom, and you take the right side and you flip the top and the bottom, and it still gives you the same equivalent proportion as long as you flip both sides. So you get x over 12 equals 55 over 60. And then at this point, you've basically reduced it to what you kind of previously had. And then the last thing is just to move whatever number is below the x and move it to the other side. And you get 55 times 12 over 60, which since I already know the answer, I'm just going to put as 11. But of course, you could go on your calculator, type in 55 divided by 12, 55 times 12, and then divide it by 60. And that will give you your answer. So that's a recap on solving these. There's a bunch of other examples, but again, these don't really change all that much. So I don't think there's much point in doing them too exhaustively. So let's go to another thing. So this is the same lesson, but I don't think we made it to the very end because at one point there is some word problems, some application problems for this, which are actually really, really useful application problems. And I've spoken to plenty of students who have said that they've used these type of application problems all the time, like in the work field. So it's something that you actually might run into realistically, especially when you're giving medication dosages, where you have a certain dose, but you need to give a different amount to a patient, and you have to figure out, what is the actual adjustment you have to make sure that they get the right amount of medication. So it can be pretty important, certainly. Okay, let's just do this. Yeah, I'll do this on a whiteboard. Hold on. Come on. Just let me catch up on my personal laptop. Okay, so new share, whiteboard. Okay, so here is a typical example of the applications / word problems that we'll be looking at. And then there's a very systematic way of solving them. Basically what you do is you end up just using proportions. So here's the first one. If there are 3 grams, I guess I should write this. If there are 3 grams of solute in 25 milliliters of solution. This writing takes so long. How many grams would be in 125 milliliters of this solution? How many grams are in 125 milliliters of this solution? Okay, so 3 grams are in 25 milliliters of solution, and then it's asking how many grams are in 125 milliliters of this solution. So we have to solve this using word problems. Okay, so the first thing you do is you set up what is called a given ratio. So the given ratio is where you pick 2 pieces of info that specifically are paired together with each other. And in this case, there's only two pieces of info that are specifically paired together. It's the fact that 3 grams of solute is in 25 milliliters of solution. There's a clear connection between those. There's no real connection between like 25 milliliters and 125 milliliters. Those are just incidental, but it does specifically say 3 grams is in 25 milliliters. So you take that solid piece of complete information and you create a given ratio with it. So you just set it up as a ratio. And in this case, I'm going to put, I could either put grams on top or I could put milliliters on top. At this point, it doesn't matter which one you put on top, but I'm going to put grams on top just for reasons that I'll explain later. So 3 grams corresponds with 25 milliliters. So you have to make sure you set that up properly and that the two pieces of info are actually like connected together. So that's your given ratio. And then the next thing you do is you set up what's called an unknown ratio. So that'll be the remaining information plus an X variable that you'll later solve for. So in this case, it says how many grams are in 125 milliliters. So since grams is what we're trying to solve for this ratio, I'm just going to put X grams. And that unknown number of grams corresponds with 125 milliliters. Okay. So that's what you do initially. And I suggest that you do these one at a time, because if you switch a bunch of numbers or get it wrong, you're not going to get the right answer. Oh, and one other thing is that you have to set them up both consistently. So notice that for the first one, there's grams on top, and that's the same for the second one. And the bottom units are also the same for both of them. So that always has to be the case. It always has to be consistent in regard to the actual units that correspond with each other. So for the first ratio, it actually doesn't matter what you put on the top or the bottom, as long as the next ratio is consistent with the first one. So, okay, so we've set this up. And now what you do is you set them equal to each other, and voila, you have a proportion, just a standard proportion that you can solve. Before I solve it, what I would do is I would remove the units, which means I would remove like the grams and milliliters. So let's just take that out. So 3 over 25 is X over 125. But just for clarification, I recommend that you do initially keep the units, again, grams and milliliters or whatever it happens to be. I recommend that you keep them when you're initially setting up the proportion, because it helps you set it up correctly and consistently. Okay, so now the rest of it is fairly straightforward. The only thing we have to get rid of is this 125 to solve for X. So let's just do that, and let's take it and move it to the other side and change it to multiplication. So this is going to be 3 times 125 over 25, which is 375 over 25, which should be 8 plus 3 is 11. So it should be 11. Is that, let's see. Oh, is that right? 375 divided by, I'm so bad with arithmetic. Yeah, okay, John needs a calculator.
15.
Okay, 15, yeah. For 11, I was like, yeah, 11 doesn't seem to make sense. So 375 divided by 25. Yes, 15, perfect. 15. And actually 15 makes sense as an answer if you just look at this kind of from a wider perspective. Like if you have 3 in 25 and 125 is 5 times more than 25, then your answer is going to be 5 times more than the 3 grams. So a lot of the times you could use different like side logic to make sure that you're getting the right answer. But again, you do still have to do it in this formal way. And then it's good to have a therefore statement. Please include a therefore statement. And you could just say, in this case, out of laziness, I'm just going to say, therefore, 15 grams is the answer. And that's a short but correct therefore statement. Or you could say, again, this is hard to write with on this pad, but you could say, therefore, 15 grams would be in 125 milliliters of solution. That would be a good therefore statement as well. So that's how these work. And they're pretty much always the same. You just look at a complete piece of info, set up a ratio for that, and then you set up your unknown ratio with the variable that you're going to solve, and then you set up a proportion, get rid of your units, and then just solve for your proportion. So it's a good systematic way of doing it. Because like with these problems, like I had a student one time who told me that she was getting, I think it was allergy medication, and the nurse did the wrong conversion and gave her 10 times the amount that she should have got. And apparently it knocked her out and like nearly killed her. So this can be important. It's giving medication to people. You got to make sure that, you have to convert between different units correctly, and, stuff like that. So it is important in the real world. Okay, what else do we have? So there's a bunch of other similar ones. I'd recommend you take a look at them and try to solve them without looking at the solution and see what you get. I'm going to clear this and let's do another one. And these are all in the PowerPoint as well. Suppose we have 33 grams of carbohydrates in a 2-cup serving of, a lot of these are so easy to guess. I need to make these more difficult. Anyways, suppose we have 33 grams of carbs in a 2-cup serving of food. So let's just write that down off the bat, because that's a complete piece of info. Those two pieces of data go together. So I'm just going to write 33 grams of carbs in 2 cups. So we got that piece of info. And then it's asking how many grams of carbs are in 6 cups. So I'm just going to put question mark grams in 6 cups. Okay, so in this case, it should be pretty clear what is your known and unknown ratio. So for the first one, let's set up your known, which will be the 33 corresponding with 2 cups. Now, like I said before, for the initial ratio, it doesn't matter what you put on the top and the bottom. But what I do is I try to look at what variable are we eventually going to solve for. We're eventually going to solve for grams. So I personally prefer setting up the first ratio so that grams is on top. And then at least later in the question, your variable will be on top, and at least you get to save like a little bit of time. You save a couple of steps. Because if it's on the bottom, then it requires, that extra step where you got to flip each side. So I try to do it that way. But again, as long as both of them are consistent, you'll eventually get the right answer. And maybe in this case, maybe we'll do it both ways in this case, just so everyone can see that you'll get the same answer regardless. So first, let's start with just putting grams on top. So 33 grams corresponding with 2 cups. And then our unknown ratio will be X number of grams corresponding with 6 cups. So again, that's why I like putting grams on top, because then we got the X on top, but that's not completely necessary as long as they're consistent. Set them equals, and now let's get rid of these units. Whenever I refer to units, I'm just talking about like grams or cups or milliliters or whatnot. So 33 over 2 equals X over 6. And good, X is on top, so that's the easiest case. So we just take the 6, move it over, change it to multiplication, and then we got the answer. 33 times 6 over 2. I guess it should just be 99, right? Yeah, 99 sounds right. 99. Yeah, because 33 corresponds with 2. 6 is 3 times more than 2, so technically the answer should just be 33 times 3. So yeah, again, those are just little shortcuts that I use, but yeah, that's just my own brain. There are little mistakes that people make with this in terms of notation. So sometimes a person will write X equals 99 grams. And that's like, it makes sense. I understand what you're saying, but if it's X equals something, you technically shouldn't have grams in there. But that's like more of an aesthetic technicality. I don't think I would take marks off for that. But it is just from a mathematical point of view, X is supposed to just represent a number. You're not actually supposed to put units in with variables, at least not in this type of statement. So yeah, for the answer, you could put X equals 99, but then it's always good to have a therefore statement that's just in words, where you just kind of give the answer in terms of what the original question was stating. So in this case, you could say, therefore, there are 99 grams of carbs in 6 cups of whatever it was. Yeah. So that's how these work. And now, just for the sake of doing both, let's do the other version where you maybe hypothetically set up your first ratio in the upside down way compared to this. And we will indeed get the same answer. So let's just do that. Maybe I should just, yeah, I think I'll just clear all of this. Okay. So same question, 33 grams in 2 cups. And then X grams corresponds with 6 cups. So let's say that you are setting up your first ratio. And let's say, so that's using this part right here. And let's say that for whatever reason, you just happen to put cups on top. Not a big deal. And then let's say you put grams on the bottom. So that's totally fine, as long as your second ratio also has cups on top and grams on the bottom. So that's the most important thing. So this should be 6 cups over X number of grams. And then you hit equals and you get a proportion. So it's not as good as a proportion because the X is on the bottom, so that kind of sucks, but it's only one extra step and you'll still get the right answer. So for this part, first let's just write this with numbers. So 2 over 33 equals 6 over X. Okay, so that's what we get. And now let's do what we did in the beginning of class. We could do that trick where we flip each side upside down. And I think that's the easiest way to solve this. So flip this and flip this. So you get 33 over 2 equals X over 6. And then you've just arrived at where you would have arrived anyways. So again, I personally like putting the variable on top that you'll be solving because it's a little easier, but that part is not essential. And then just take your 6 and move it over, change it to multiplication. 33 times 6 over 2. So that should still be 99. So therefore, 99 grams. And that's basically all you have to do for these word problems. Yeah, they're pretty much the same. Yeah, it's very algorithmic. Like you can't really, there's not really a lot of curveballs thrown towards you. One problem that does arise is that people try setting up both ratios at the same time and they just throw everything in randomly and it never makes any sense. Like I'll see people who will do like 33 grams over X grams equals 2 cups over 6 cups. And it's like, none of this has any, yeah, none of this is gonna work if you just throw everything in there randomly. So I recommend just doing this one separately and then doing this one separately and just making sure that everything is together. Actually, yesterday I was teaching this exact presentation and I took this and I tried to come up with like a mixed up example where it's all wrong. And I accidentally wrote an alternate version that was completely right. So it was just funny that I couldn't even accidentally make a mistake in that circumstance. The students were like, that actually works. And I was like, darn it, I was trying to make it not work and it works. But yeah, let's see what else we have. So let's go to, here's just a general guideline for how to solve these. Let's go to new share. Here we go. Let the unknown quantity be represented by X. Use the given information to set up a ratio of, quote, known values and a ratio of, quote, unknown values. Set these two ratios equal to one another, and that creates a proportion. Be sure that the same units are in the same position in each ratio. So if milligrams is on top for one, it has to be on top for the other one. And then drop the units and rearrange things to solve for X, and then answer the original question that was asked. Because this is an application problem, so you should state it in terms of the original question. I'm just trying to look for some, like a lot of these are too easy. They can be guessed very easily. Let's just do one more. Okay, this one is maybe a little harder to guess. Okay. Let's do this one. 2 cups of fat-free milk contains 115 milligrams of sodium. How much sodium is in 2.5 cups of fat-free milk? Okay, so what is our complete piece of info? It would be 2 cups corresponding with 15 milligrams. It would be that piece right there. And what are we going to be solving for? We're going to be solving for the milligrams of sodium. So I'm going to put the sodium part on top for a first proportion. 115 milligrams over 2 cups. So set that up separately on its own before you do the next one. Next one should also have milligrams on top. In this case, it'll just be X milligrams because that's what we're trying to solve. And that corresponds with 2.5 cups. Set them equal, and then you got a proportion. And now drop your units so that you just get numbers. And then, of course, last step is solve for the remaining variable, or the only variable. So 2.5, move it over there, put it on top, and you get X equals 115 times 2.5 divided by 2. And hopefully that's right. Let's see what the answer is. It is 143.7. 0.75. Yeah, 0.7 would be weird. Usually it's like 0.75 or something. 143.75. Oh, hold on. Sorry, I have to sneeze. Apologies. Yeah, and in this question, you could kind of take a step back. Like this answer seems very reasonable, because if 2 cups have 115, 2.5 cups is not that much more. So the answer should be like a little more than 115 milligrams. And we end up with 143.75, which seems proportionate to what we need. No pun intended. So I guess that's it for word problems. We skipped one, so use this one for practice right here. Okay, I guess that's, let's see, let's just stop sharing for a second. These fruit flies are driving me crazy. Okay, does anyone have any questions? So I was gonna do one last thing. It's kind of a weird, random, unusual thing, but it's something I wanted to do for one of my classes. I wanted to end a class by reading an inspirational quote. I've been writing a fiction novel, so I've been reading like a lot of quotes, and all my friends are tired of me sending them quotes. So I'm going to read everyone an inspirational quote, and maybe that'll put everyone in a good mood for Thanksgiving. Yeah, that's what it is. Let me just do the attendance for a second. I think I got pretty much everyone. Oh, we need this person. And oh, that person. Anyone else? Anyone else? Okay, I think that's everyone. Okay. So I'll read the quote and then we'll be done. Still no due date for the second assignment. Again, once we just cover the whole chapter, then we'll decide on the due date for that. Okay. And should I keep this in the recording or should I not? I'm going to pause the recording for this.